Through smart grid and smart city solutions, Trilliant helps communities and utility companies worldwide accelerate their path to the energy transition. Combined with next-gen network technologies, AMI, analytics, smart street lighting, and more, our unique device-independent platform offers unmatched flexibility and interoperability to meet the needs of every customer we serve. Utility companies trust us to provide essential, reliable, smart metering and smart grid solutions layered with scalable, secure networks for optimized performance, efficiency, and system reliability. With multi-technology global applications that grow with the communities we serve, we provide a secure foundation of connectivity to transform cities, buildings, lighting, and more, while supporting critical sustainability goals. Flexible, scalable, sustainable, essential. Trilliant. Let us help you discover the power of choice.
A very good afternoon, ladies and gentlemen. Good day to everyone. Let me just a brief introduction of myself. I'm Eugene Lok, Managing Director of Trilliant Networks in Asia Pacific, with over 30 years of experience in tech, particularly in enterprise software, AI, APM, ERP, EAM, AMI, as well as industrial IoT. My domain knowledge in energy sector includes generation, transmission, and distribution. Today, I'm excited to represent Trilliant and share my thoughts on the topic of rethinking distribution in a smarter grid era, and subsequently at a panel discussion to give my view on some of the key topics in this area. In this presentation, I'm going to touch a bit on who we are, what we do, and I will also share with you, in my opinion, the evolution of grids modernization, its opportunity, followed by conclusion. Trilliant was established in 1985. We bring with us more than 30 years of pioneering experience. We developed the world's first interval meter communication device back in 1985. We launched our first mesh network in Milton Hydro in Ontario, Canada, back in 2006. With more than 200 customers globally in 30 countries and counting, we are reaching to more than 500 million end users with our Trilliant platform, covering more than 37 million endpoints. We have almost 100 patents across the world, which solidify our pioneering status. Since 1985, we have been driving real change in energy and utility sectors. Our team's passion for innovation has made Trilliant a go-to technology partner for companies seeking outcome-driven solutions. Our award-winning multi-tier network solution, designed to support your mission-critical AMI application, together with our device independence head-end system. In addition, we also offer smart city, smart building, advanced analytics, to drive data-driven outcome. Our solution platform was designed to give our clients the power of choice. And it is just not about tech. We are committed to sustainability, as we are one of the participants in UN Global Compact initiative, and we are also a DECRA certified organization. Our platform enables distributed energy resources integration onto the grids. We also enable energy storage planning, smart city, smart building, high-performance bi-directional communication, real-time data for supply-demand balancing, advanced analytics for data-driven insights. In short, we empower utility to optimize grid operation and unlock new opportunities. The traditional grid, built nearly a century ago, faces challenges with increasing demand and sustainability. With its unidirectional system, it has just enough surplus capacity to ensure reliability. According to US Energy Information Administration, EIA, the world net electricity generation is forecasted to reach a whopping 37 trillion kilowatts hour which represent a rise of almost 70% by 2040, comparing to 10 years ago. Radical changes are needed. The smart grid emerges as a solution. What is smart grid? In my opinion, smart grids are grids that are transparent, seamless, allow instantaneous bidirectional flow of energy information system, allow real-time information exchange, enable near instantaneous with efficient supply-demand balance, a system that provides customer empowerment, and an infrastructure that allows renewable energy integration. By embracing smart grid technologies, we can create a more sustainable, efficient, and responsive energy system. Smart grids involve the deployment of smart hardware, including smart meters and network, collectively known as advanced metering infrastructure, in short, AMI. The deployment of AMI is expected to be accelerated as a result of increased affordability of devices. Smart meters enable the very first non-threatening steps towards migration to a smarter grid. Smart controls and AMI provide high-resolution data regarding flow of power. The smart grid makes the grid smarter and will generate efficiencies in electric power distribution. This network will consist of detection, measurement, control devices with bidirectional information exchange. As such, this gives utility stakeholder real-time update about network condition, enabling them to take instantaneous action to correct the grid. Ultimately, it aims to empower customer, improve the transmission lines, distribution system, provide information and accurate pricing for consumer and supplier, and capitalize on renewable energy sources. With the adaptation of AMI in grid modernization, it promises numerous benefits for utility and customer alike. For utility, meters are now read more accurately and automatically, meaning timely billing. Introduction of new business models such as time of use and prepaid. Improved outage management system. It also provides data insights, meaning utility can make data-driven decisions. Changes like distributed generation and EV charging become easier to integrate into the distribution system, and many more benefits. As for consumer, since the consumption data is now readily available on your mobile apps, consumers are now empowered to better manage their energy consumption. Outage management and restoration alerts can also be available in your mobile apps. Participation on demand response and time of use program for better tariff incentive. More importantly, integrating RE onto the grid, even incorporating energy storage as part of the prosumer ecosystem, which will be significantly easier. The opportunities are present along the power industry value chain, from generation to customer relationship management. As utilities pursue these opportunities, the effects are already felt by many retail customers. Many utilities have launched mobile applications for billing, bill notification, bill presentment, payment, as well as outage management. They are more to offer than just billing. In the very near future, mobile application will extend into smart home and connected buildings. Digital management of distributed energy resources from individual sites to entire system has already begun. Many projects within the utility have a digital focus and are using techniques of digital economy. If you look at the diagram on your left, digital opportunity to improve operations and increase flexibility are available throughout the value chain. Conservative estimates supported by analysis of real-life cases suggested that digital optimization can boost profitability by 20 to 30%. Utilities can realize most of this potential by three means: advanced metering infrastructure and smart grid, digital productivity tools for employees. Last but not least, automation of back office processes. This innovation leads to increased efficiency, reduced costs, and improved decision making. The evolution of smart grid is direct result of digitalization. It changes the industry boundaries and dynamics. I believe to articulate their digital vision, company must first identify the position they want to occupy on the digital terrain with respect to data, services, and devices. Let's look at the new frontier illustrated here. For example, in distributed generation and smart grid, AMI provides energy supplier with the exact detail of each customer's generation and consumption. So on this basis, utilities can provide tailored products such as demand response program, data-driven maintenance contracts, new business model to enable utilities to eventually own the distributed facility. On the other hand, smart home, connected buildings, smart cities, many utilities already offer solutions for network energy management that includes the remote control of buildings. Utilities can use the information from their smart meters to realize additional application in this new business area. As daunting as digital transformation program might appear to individual companies, the potential opportunity is worth many times the attending cost and risk. The change is inevitable. Digital forward sectors such as retail, financial services have already demonstrated that value in digitalization is greater than anyone predicted. Utilities that undergo digital transformation will better equipped to face future market challenges. This will be my last slide. The energy transition relies on a balanced approach, with distribution networks being just as crucial as DER, EV adoption, and energy storage. While the smart grid injects intelligence into the current power grids, the Smart Grid 2.0 represents a technological leap, enabling bidirectional energy and information flows, which some people will call it the Internet of Energy. Edge computing on the grid will be a reality with active network management via advanced power electronics, together with miniaturization and remote management of grid's component. The next generation power grid is being explored globally, with the US allocating $3.4 billion, according to Department of Energy reports, DOE reports, to develop Power Grids 2.0. The focus area is on advanced power electronics, smart meters, and broadband technology, with the goal of enabling renewable integration, bidirectional power flow, grid security, and stability. European partnership aims to upgrade utilities from smart grid AMI to grid 2.0, focusing on distribution automation that will enable self-healing, digitally controlled network, and improve reliable power delivery. The power industry value chain from generation, transmission to distribution and retail generate huge quantity of data, and if subjected to the right analysis, this can deliver crucial insight into business processes, technological development, and societal needs. Meeting commitments on carbon neutrality while addressing the rising global demand for energy requires new technology, new business models, and improved collaboration. Finally, digital technology is a crucial part of our drive for decarbonization and is creating opportunities across business areas. Technology is important, but a large part of the challenge is about cultural transformation. Lastly, climate change is real. We, the citizens of Earth, need to take drastic steps, and the action is now for us to harbor any hope of achieving carbon net zero. Thank you very much for attending this session. Thank you to Enlit for the close collaboration. I shall pass the floor to Zhen Hui, our moderator.
Yes, hi. Good afternoon, everyone. Thank you, everyone, for joining this webinar. This is a very important and pertinent topic. Please allow me to do a short introduction. Then I would like to request for each of my panelists to also introduce themselves. And first up, thank you very much to Eugene for the presentation on the different smart grid applications. And of course, really looking at the different advantages and the ROI that can be achieved in order to achieve the goals for your utilities, for your organizations that you have been, shepherding and managing. Smart grid technologies have advanced significantly in recent years, right? Digitalization of grid, sharper analytics, and enhanced outcome for utilities as well as consumers. And today we will hear from four esteemed panelists really to share their perspectives on how smart grids have been deployed in their organizations, case studies of the benefits, as well as looking at the challenges that they face along the way so that we can all learn from each other. Now, I would like to invite Park Yoko from PLN in Indonesia, Anton from Aboitiz Power in Philippines, as well as Kun Posakon from PA in Thailand, to give a short introduction of themselves. Park Yoko, maybe you can start, Park Yoko.
Yes. Good day, ladies and gentlemen. Please introduce. I'm very glad to be here with you all, and I would like to introduce myself. My name is Ignatius Rendroyoko, and I'm working for PT PLN Persero at this moment as EVP, Executive Vice President for Distribution System Strategic Planning. My main job is to formulating the strategies in order to develop a reliable and efficient electricity distribution system that enable to provide electricity supply to all Indonesian PLN customers. At this moment is around 92 million electricity customers in Indonesia, and my duty also preparing short-term and long-term distribution planning in providing electricity supply. At this moment, PLN now entering digital transformation also for all the facilities in electricity system by also including the technology of telecommunication and information technology to provide the latest distribution system with advanced distribution management system, outage management system, automation, SCADA, and also we are preparing to receive many many renewable and renewable power plants. Yeah, that's now is developing the technology, and hopefully we are capable in developing the latest technology, the modern system for our distribution system, enable to provide all the electricity customer with reliable, efficient electricity supply with the minimum operation electricity costs. That's it for me, from me. Thank you very much, and I'm happy to join you in this event. Thank you very much.
Thank you, Park Yoko. Maybe I can swing over to Anton from Aboitiz Power. Maybe you can give a short introduction.
Hi, good afternoon, everybody. My name is Anton Perdizas. I am the current Chief Operating Officer of the Distribution Utility Group of Aboitiz Power. We're one of the largest conglomerates based in the Philippines. Under my leadership, we currently have 4 cities where we maintain the power distribution utility grid, and we have 4 industrial zones. We have about a little over 600 megawatts in demand throughout our different utilities, and we're currently serving over 1 million customers throughout those different utilities. We are currently in the process of upgrading our network to smart meters. However, there's a challenge that I can get into more briefly when it's time for the question and answer session. Thank you.
Yes. And may I also invite, last but not least, Kun Ponsakon from PEA.
Hi, everyone. Good afternoon. My name is Ponsakon Yutakowit. I'm a Deputy Governor for the Planning and Engineering for the PEA, Provincial Electricity Authority of Thailand. PEA is one largest distribution utility in Thailand because of we have only two distribution utility in Thailand. Because of our service area cover 74 provinces, you know that only 3 provinces covered by the MEA, another distribution utility. For my duty, I work for PA almost 26 years already. It start from the planning engineer, right? We do some feasibility study to do distribution expansion, and recently, last 10 years, right, we have in the era of the smart grid, right, we need to change our infrastructure to be the more sensor, more smart meter, right? And also am was the project manager of the AMI at the Pattaya City since almost 5 years ago already. And the project is quite well, and we learn a lot from that project. I think in another session, I will describe about how PA developed the smart grid roadmap and how we implement our smart grid further. Thank you.
Yes, thank you. Thank you. Thanks very much. And I think that, with the background of the esteemed panelists, the kind of infrastructure you're managing, as well as the different large-scale consumers that you're serving. I think, Pak Yoko, you mentioned 92 million customers. I mean, that is a very large number. Can I request that each of you to provide your views on where your organization is in the journey in terms of smart grids deployment, and really what are the overarching goals that you're seeking to achieve for your organizations? What are the benefits that you can draw from there? Pak Yoko, maybe I can ask you to start.
Yes, thank you, Mr. Chen Sui. PLN now, with high growth of electricity, we are expected to grow more than 8% this year, from around 6% last year, PLN. We are now trying to develop our smart grid electricity system that covers all the sectors of electricity infrastructure, started from power generation, transmission, and also distributions, and also all the infrastructures goes to the customer in retail business. And at this moment, how we trying to develop our smart grid is using the latest technology that enable us to enhance our reliability system, how the customer can get the uninterrupted electricity supply, so that the condition of their activities, in their business activities, industrial activities, can be guaranteed. So the energy consumed by each sectors of the each sectors of the electricity, the residential, business, industry, and also public, has all the capacity, all the support to be able to develop, or to be able to increase the economic growth of Indonesia. We are trying to transform our electricity system from with 92 million of customers now consists of 40 million customers is still using old technology of postpaid meters, and prepaid meters is reaching 60 million. And now we are changing the technology into the smarter technology of advanced metering infrastructure. And we know all that the AMI system, advanced metering infrastructure measuring electricity measurement system, is the base of the smart grid technology that will enable us to have the continuous electricity supply, continuous, adequate, reliable, and with the low cost of electricity. So all the customers in Indonesia still have the will have the cost of electricity, the low minimum electricity cost for doing the activities in economics. That's all from me. Thank you so much.
Thank you. Thanks very much, Pak Yuko, for sharing the overarching, scenario and the situation that you have in your utility context in PLN. Now, there's a question that has come in from the audience. If it is all right, just to keep things interactive, I will ask this question. How many smart meters are already installed in PLN? I think that there's a roadmap and there's a progress. And what type of communications system is being used for these smart meters, right, to communicate with the backbone? Yeah, so please.
Yes, thank you. At this moment, we are in the process of developing our advanced metering infrastructure. We have the first project is 1.2 million customers, and we are now trying to continue to continue it with 1.3 million AMI meters. However, we at this moment we are already also we are operating the technology of advanced metering automated meter reading for industrial customer with the class of industrial and business customer about 20 kVA, 197 kVA for that class of customer. We already have provide the technology of automated meter reading. We have a roadmap for implementing the AMI technology. Yeah, the AMI technology will be our main technology to develop in the future. We plan to transform. We have a plan to change our meter technology started from 2023 up to 2035. It's a 15 years time with 35 million customers converted into AMI technology. That is the very hard job to do. And at this moment, the communication media we operate now is we are using the GSM, the GPRS, and also for that is for the automated meter reading technology for the business and industrial customer. And for the AMI system, we are using communication media of HPLC, power line communication. And this period, we have a proof of concept project, especially designed for testing the communication media. Our proof of concept project is designed in Nusa Penida Island. Nusa Penida Island is a small island southern of Bali Island. This is very interesting project because eight of major communication provider, smart grid communication provider in the world join us to show their technology, and we are very interested in learning and to see how the technology of the 8 communication media provider will perform for connecting the advanced metering infrastructure meters. That's it. That is our the latest project, and we will finish this POC project in this month. Hopefully that will give us lesson learned, which is the good technologies that can be used by PLN to be able to develop the Army projects in the future. We have the technology of HPLC. We have technology from Trilliant also. Trilliant also join us in the POC project, and we also have the RPMA. We also have the LoRa technology and others, yeah, and the combination of it, and hopefully the project will be delivering a good result for PLN to choose. Thank you so much.
Yes, thank you, Bang Yoko. Thanks very much. And that sounds like a very ambitious program, also with a lot of technological complexity to manage. Now I'll move over now to Anton to ask, how has Aboitiz been thinking about smart grids technology, where you are in terms of your journey of deployment, as well as what are the overarching goals, really that you like to achieve that is suited to local contexts in the service areas that you serve.
Okay, so if we start with the beginning of the distribution line, we are slowly starting to convert our substations to digital substations using the IEC 61850 standard. The advantages there, we all know, is less cabling, less wiring, everything's fiber optic, and it's an unmanned substation. We can more effectively monitor all the equipment within the substation. So that pretty much takes care of the maintenance and the operation of the substation. Then as we move along to the meters, currently there is a contestable and captive customer within our utility. The contestable customer has the option to choose where to purchase their power directly from a generator through a retail electric supplier. The threshold right now is down to 500 kilowatts. And what our regulatory commission did was also put together a green energy option program to allow 500 kilowatts to 100 kilowatts to be able to become a contestable customer so that they can choose. Another thing that our Energy Regulatory Commission is doing is also rolling out the concept of retail aggregation, wherein if you live in a subdivision, you aggregate all your load, your demand, and you can become one contestable customer and purchase directly from the generator. Also, if you're a single owner of multiple entities, you can aggregate those as well. That being said, all these contestable customers do need to have smart meters because the data needs to be transmitted initially on 15-minute intervals, but now they're looking to push it down to 5-minute intervals of data. So that covers most of the contestable customers that we need to service. We're also in the process of, we have implemented we call them lifeline customers. These are about 60% of our customers that consume an average of 100 kilowatt and below. These are the urban poor. So we've been working with a US company called Vision. They have co-developed with us a smart meter called Hawkeye, which is an elevated box that helps us to also directly read, connect, remote read, disconnect, and connect to assist with our pilferage in reducing the pilferage. Along that line, we have implemented several automatic load break switches and auto reclosers to be able to pinpoint exactly where the faults are in our network whenever there's an outage, rather than having to send an emergency crew to follow the line. These auto reclosers try to reconnect to close the network in milliseconds, about 3 times. If it can't in 3 times, then we send somebody to check and see where the outage is. That's all that we're doing. We're also starting to look for ways to increase our smart meter rollouts. Now, the concern we have is that the regulator obviously wants to try to give power at the cheapest rate. And we all know that smart meters are much more expensive than dumb meters. So there has to be a balance. And we're working on that with the regulator to see which is the best way to implement it without significantly impacting the price of consumers. Because if we roll out all of a sudden 1 million smart meters, the price of power is going to go up. And it's one of the issues that we currently have in the Philippines, where we have compared to our neighbors, higher energy prices. So that's kind of the challenge we're facing today is that balance.
Yes, thank you. Thank you. Thanks, Anton, for explaining the local context, right, of what your organization is using smart grids and also AMI meter. I know you touched upon outage management, which is something that we'll also talk about later, maybe in some detail. Now, I'd like to finally also turn to Kun Posakon to ask you, to explain some of the context of the work that you're doing in PEA in Thailand with regards to smart meter deployment and overarching goals, please.
Yeah, thank you. I need to explain about we have the strategic positioning during 2-3 years. We should have developed the digital and green grid that we intention to have some sensor in our system. And one of that we implement already that we have we call AMI it for the last customer and industrial customer. If Eugene know already that one phase will use the Trilliant product, right? And also I think right now we need to fulfill our last customer. Last customer is mean that at the customer that connect at the medium voltage, look like a 22 kV for us. And also we have the pilot project in Pattaya City that for the residential or at the low voltage customer around 100,000. Right now, if you ask that for the AMI that PA have right now allow close to 300,000 AMI meter already. That, but we have the next step to develop further. We look at how we go into the 1 million AMI meters. That if hope so that in next 4 years we can do this one because of that Antoine mentioned about the cost, right? If you look at the smart meter cost is too high, when you compare with the traditional meter, might be 5 times. I think it's 5 times when you compare with the traditional cost of the smart traditional meter and the smart meter. I know that the technology will develop further and further, and cost will dropping down. And we need to find the another benefit. Look like that in in Philippines, right? If you want to get the power or trade the power, you need to have the smart meter. That is the benefit to the customer that to use the smart meter is another key to drive the customer to have the smart meter because of they get the benefit from that. But for the PA, I think we on the phase to debating because we propose the another close to 1 million smart meter for the residential customer to the our regulator. We need to defend that how we utilize that the smart meter, the program for the 1 million meter that utilize to get the benefit, just like we operate more efficient, we get the benefit to the customer. That's why they need to have the smart meter for this. I think it's a long process to do this one. and next step, in another next 5 years, I look at the smart energy solution. It means that everyone can use the EV charger at their home. They should have some own local energies, look like the solar rooftop and their BSS, right? That they can realize or resilient on their system. It's another point that we need to have some more sensor, more AMI meter, more sensor. Maybe we have some point to install the meter or I don't know the sensor at the distribution transformer to checking about the network, how we can, balancing the fate, how we can reduce the loss, something like that. Because of one point when we thinking about the smart grid, it's not only the equipment, it's about the integrated, the data that we collect in the grid, and we need to visualize the way that this part have some problem. Because of when they have some problem right now, we just try out and error. We have some assumption that what the problem will occur on transformer or occur on low voltage, right? If we have the data from the transformer and if we have the data from the inverter, we can, closely to analyze that where they have the problem, just low voltage, or maybe have some fault on the distribution transformer. Might be easily to find and make the short time to more good for the service. Right now, we on the process to try out to do this one, but I can imagine that if we can do this one, it's similar like that. We can get a better operation on the grid. That's the way we move forward. Thank you.
Thank you. Thanks, Khun Pongsakorn. And I think that you raise, important points about how smart grids, enable that kind of data collection and data analytics, right? And that will really then drive towards certain enhanced outcomes. Now, here I would like to invite Eugene maybe to share some thoughts on how AI is actually used on this analytics that's collected in the smart grids. And it's also one of the questions that has come in through the audience. Eugene.
That's a pretty tough question. In fact, AI is still at the infancy stage, and the good things is about AMI able to present enormous amount of data, which utility could actually use a lot of advanced analytic. Advanced analytic versus AI. Advanced analytic is a trained model to unlock this value as of now. Analytics enable utilities to process and interpret this data effectively, perhaps for operational improvement, for forecasting and simulation. That being said, one of the analytic that Trilliant has to offer is to look at non-technical loss. Non-technical loss, because as far as AMI implementation is concerned, we have seen a real life customer that reduced the non-technical loss by 50%. However, that still do not stop them tampering the meters and go beyond beyond the meter to basically on power theft. So on this aspect, our analytic go beyond just a pure meter read comparison. So we look at some load data and behavior. So from there, we will actually provide the reports from that perspective. So AI, in times to come, it will be incorporated in such data analysis on those humongous amount of data that will be available.
Yes, great. Okay, thank you. Thanks very much for that. Now, I know that from the audience, there are some questions on related to the cost-benefit analysis of deployment of smart meters. And really, we do know that at least in the very immediate term, one of the benefits is around billing efficiencies that can be achieved, right? Be it that you have a mobile app, be it that you're able to streamline your operations without having physical collection centers. Maybe can I invite Park Yoko to share a little bit about the billing efficiencies that maybe you have been able to achieve in PLN?
Yes, Mr. Sen Hui. For us, by implementing our first AMI project, actually we are now still trying to use all the data that we are collected from the Army projects. Firstly, we are trying to reduce our energy losses in that system because on the first stage, we are implementing the Army system in 8 cities in Indonesia, in Banten, in Jakarta, in Bandung, in Semarang, in Surabaya, in Denpasar, and also in Makassar, and also in Medan. And using that environment, using that system that already transformed into ARMY system, we are trying to collect which is the information, which is the indicators that saying that's an illegal usage of electricity. Using that data, we are kindly knowing, oh, this is we can collect all the losses, not only non-technical losses, but also technical losses. Yeah, and we are beginning to see, beginning to enjoy that this technology do help our engineers, our operators, knowing and finding and also getting all the illegal use, electricity illegal use in our system data. And this will be the positive way. This is the positive things that we are learning from the Army. And by using it, we are more than confident to develop our Army projects in others area. This is the first time for PLN to know exactly how the electricity is distributed, and also measure it accurately to find out to measure the electricity energy losses. That is the lesson learned that we have from our projects. And yes, I agree with Pong Sangkor and also Pak Anton that we have to invest more for the meter of Army, because the price is in Indonesia right now is 3 times compared to the prepaid and postpaid existing meters. That is the one thing that we have to show, including we are trying to have support from Indonesia government for Army project, because this is the first proof, the first evidence of the utility to have digitalization, digital transformation of this business. That's all, Mr. Suri.
Yeah, thank you. Thanks, Pak Yogo. I'm going to come to Anton and to talk about the specifics in the Philippines market or Aboitiz Power's service areas. I'd like to ask, I mean, you talked about, okay, the power prices in Philippines are maybe a little bit higher as compared to the ASEAN region. Now, with regards to that, would it be actually easier to digest or to amortize the cost of smart meter? Because on a percentage basis, actually maybe the increase is not so large. But importantly, also maybe if you can share some thoughts around what are the efficiencies that are harvested that can, of course, be plowed back, right, as ROI into this investment. So, Anton.
Yeah, so again, as I mentioned, right, we're really looking at a balance on who to implement smart meters with and who not to, because number one, as mentioned earlier, a smart meter is, last I checked, it was between 3 to 5 times more expensive than a regular meter. And that included plus the cost, since labor is very cheap in the Philippines, to be able to have somebody go read a meter and then submit a bill. It's still not as cost effective than going full smart meter. Otherwise, we would have a regulators telling us to go 100% on smart meter technology. That being said, we're targeting certain areas and customers where it really does make sense. And as we know, technology always does get more affordable as it gets implemented, right? You talk about cheaper solar panels, cheaper meters, cheaper everything as innovation comes into play. So hoping that in the future, with the reduction in prices, we can really look at making a stronger push to implement more smart meters throughout our organization.
If I may add, Zhen Hui.
Yes,
While
please.
I don't disagree with Anton's saying that on the balance of the price, the cost and benefit analysis, but I strongly suggest most utility have to go beyond billing. If we just focus on pure billing, so that's where the cost factor will come into the equation. More importantly, I think the implementation of AMI, we have to look at defining the short, medium, and long-term objective. So looking at some of the program, the business model that the utility able to implement, such as time of use, with the attractive tariff, and more importantly, is about education. Customer need to be informed of the benefit, and they need to buy in and subscribe to such benefit, both tangible and intangible. The success of AMI will largely depend on the take-up rate. So, and in some country, for example, in Singapore, I need to pay for a smart meter, but not some country, the smart meters are free. So consumer needs to, when they understand such benefit, knowing that the smart meter able to look at the renewable generation, as well as they are able to subscribe to certain program, I think that could potentially outweigh the cost factor. And lastly, I think regulatory hurdles is important. At times, regulator needs to see beyond just tariff or cost versus their energy transition initiative. So, and I'm sure you guys are also aware that in the recent concluded ASEAN meeting, which the ASEAN, I think most the government in ASEAN agreed on a ASEAN Power Grids initiative. That will basically, the intent is to make it more, to address the security and address the stability.
Yes, thank you. Thanks, Eugene. I think that's an important point to raise. Indeed, I think that for smart grids deployment, there's a broader piece that's just beyond the billing efficiencies. Now, in this case, I'd like to turn to Khun Ponsakon. Now, I like to request if you can share some things about outage management, particularly in a crisis situation. How has PAA thought about deployments of smart grid? How can it be helpful? And also the speed of restoration of service, right? How smart grids can allow your teams to be sharper in terms of both identifying but also informing the customers of the outage. Khun Ponsakon.
Yeah, really good question. And more difficulty to answer right now about the crisis management. When we have the outage, just like have the really strong the disaster, in our area, right? But I think the smart meter will inform us about which area that have outage, and our team will maybe have the view of the outage, and we can manage the light crew or the team to fix it better than we didn't know about the outage will occur somewhere else, right? And the AMI will show us which area that very important, just like you can identify the important customer that we need to recover first, just like the hospital, just like the government area that we need to recover on that first, right? I think the concept is good, but in the reality, I need to ask a thing about the process. When they got the data from the smart meter, how we visualize that in the way that we can manage the system. Because of the meter send the outage notification back to the data center, right? And we need to view it just like the outage maps. Then they need to realize that area, which area is more important that we need to recover first, right? And which area we need to and let's say that leave it for further, but because of we need to manage which one is really important to manage this one first, right? That I think in the term of the crisis management, I think it's a better view to respond to our customer. I have some idea because of when we do some project in Pattaya, we try to develop some outage map, right? Because of if we have the view on that, right, we can give the customer the information that when they have outage occur and when we need to get the data back, we can recover the power back to the customer, something like that. But the concept is good, but in the reality, we need to have some process to inform the customer, right? I think right now is I heard some utility in USA, some utility in some area they inform customer back via their application, but they need have some process, integrated some application and system, right? And for example, is a customer information system need to integrate with the AMI system, right? To inform customer back where they want to get the information and how we can recover the system. Just an idea, but I cannot say that we successful to develop on this, but just a trial to do and hope so in the next phase we should have developed the better to manage the outage. Thank you.
Yes, thank you. Thanks, Kumpusakon. And I will just maybe talk about an idiomatic expression. Journey of 1,000 miles start with a single step, right? So, it's very good that I think that you are already thinking of the single steps and the small steps along the way to progress. Yeah. Now, I think we have time maybe for one final point from Eugene. Now, I'd like to ask you if you can elaborate from your experience in the Asian context, how utilities have found it useful to deploy smart meters to facilitate the energy transition, be it from the prosumer perspective, managing of rooftop solar perspective, also energy storage perspective. Eugene.
Well, unfortunately, I think when the topic is on energy transition initiative, smart grid is often overlooked with a priority on generation, distributed energy resources, and energy storage. Those are the main topic. And in terms of smart grid readiness, I believe country like for advanced economy in Asia Pac, I'm talking about countries like Australia, Japan, Korea, or perhaps Singapore. Maybe we are just a little bit off. We are pretty ahead in this aspect. If you look at Singapore has piloted smart grid technology and focused extensively in making us Singapore grid as one of the most stable in the world. And Singapore has set forth to develop a very cost-effective energy solution to improve energy efficiency and its carbon emission, broaden its energy option. I'm sure this when we present what I presented just now in my deck, we also talk about some of the key benefits that the end user, the customer themselves need to realize that smart grid AMI is a journey. Journey in the sense that it is not about a year or two. We are talking about at least 5 to 10 years journey. So selecting the right technology, and it has to be device agnostic. Selecting a communication platform that is bidirectional instead of unidirectional. So that will allow you to do a lot more, implement a lot more application in addition to just pure billing. That's all. That's all for me.
That's great. Thank you. Thanks very much, Eugene. Yeah, no, thank you. Thanks for those thoughts. We are at time now, straight on at 4 p.m. Singapore time or 3 p.m. Jakarta time and 3 p.m. Bangkok time. I will proceed to close the session, but first, please allow me to take an opportunity to thank all our panelists for sharing your insights, use cases, the benefits, but also some of the challenges that you face in your daily work in terms of smart grid deployment, and that has brought some insights, for our audience. Now, also, final word to thank the audience. Thank you very much for active participation. We have gotten many different questions, and this has made for a very lively discussion. Thank you very much.